Right. I mean the slide that contains the today's presentation. Have you seen my screen? No?
Not yet, not yet.
Okay, okay. Just a minute. Yes, okay. Let's see. Is it visible? Is it okay now?
Yes, yes.
Okay. I think my computer is slow, so please wait. Yeah. Okay, now I'm going to start today's class. Are everybody okay? Okay. Hello, everybody. Today, I'm going to present about the non-destructive test of steel materials. And I'm the instructor of this class. My name is Susan Tripathi. And the chair of this class is Sarania. Okay, you can see the device, right, that we use in this experiment. Mainly, we are using 3 devices. Basically, in today's class, we have 2 sections. That is, in the first section, we will discuss about the measurement of the thickness. That includes the thickness of the plate and the thickness of coating. And in the next section, we'll discuss about the testing, ultrasonic testing for the detection of defects on the welding. I think you know about the welding, right? So, okay, I'm starting from the first section. In this section, our objective is to learn how to measure the thickness of the steel plate and the coating thickness of the steel plate. For this experiment, basically we need the steel plate as a material. And then I have missed something here, that is the gel, ultrasonic gel, right? Which is also called the couplant. I will show later. And then the apparatus is the equipment. The apparatus are used, 2 apparatus are used for the different purpose. For the first, ultrasonic thickness gauge equipment. You can see the figure here. And then, yeah, this ultrasonic thickness gauge equipment is used to measure the thickness of the plate, actual thickness of the plate. And the second one is coating thickness measuring equipment. You can see in the figure. Okay, I will discuss in detail these things in later slide. Okay, now I would like to explain about the basic principles, how it works. First of all, you have to know about the NDT. What is the NDT? Actually, it is the test. During the performance of this test, during the test of the non-destructive testing, at that time, the main structure will not be damaged, right? The structure should be the same, but we can assess the properties of the material. That's why it's calling the non-destructive. Yes. After that, the ultrasonic thickness measurement method, or this technique, how it works, a method of performing the non-destructive measurement of the local thickness of a metal plate based on the time taken by ultrasound wave to return to the surface. So where it used? It is used to inspect the metal thickness of ship hulls, piping, and structural steel. Basically, in this experiment, we are using the structural steel test. Here you can see the figure. right? Yeah. And how it works, mathematically how it works. So to find the length of the, to find the thickness of the plate, which is also called the path length of the wave, that can be found by using the simple relation where Vs is the velocity of the sound and this t is the time taken to travel by the wave. And why we are dividing by the 2? Because the wave starts from the surface and go back to the another backside and return back again. So it travels 2 times at the same thickness. So we are dividing by 2 to get the actual thickness. Okay, these relations are used by the device to display the accurate thickness, actual thickness of the plate during the measurement. These are the steps that we follow during the test. First, we apply the coplant, which is also called the gel. It's like ultrasonic gel on the surface of the inspecting area. And then we place the probe on the surface. You know the probe? I think it's, I think you know about this. If you don't know, you have to, this is the transducer. This probe is also called the transducer. It's like a small device that helps to detect the wave. Okay, I will show later these things. After that, we read the value in the device monitor. We can see the value here. If you see in the figure, we can see some value. And then we record the readings. And in your report, you should include that value. Our TA, Sharanya, will display the overall procedure in the video later. Okay, now next step is to measuring the thickness of the coating layer of the steel section. Why the coating layers are provided in the steel? Basically, it is used to prevent from the rusting, something like that. So we can call as protection. And next one is decoration purpose, right? So if we want to find the thickness of the coating layer, then we have 2 methods, 2 principles. That is magnetic inductive methods, which is also called the Ferris method. And next one is eddy current principle, which is also called the non-Ferris method. Here you can see equipment. This is for the Ferris method. And yes, and what is the magnetic inductive principle? How it works? Magnetic inductive principle is used to non-destructive, used for the non-destructive coating thickness measurement on magnetic metal. That means the iron and steel coated with the non-magnetic coat. That is varnish, paint, enamel, plastic, glass, aluminum, lead, chrome, etc. That is the non-magnetic coat. And next one is eddy current principle, which is used for non-destructive coating thickness measurement on non-magnetic metal coated with the electrically insulating coat. So there are 2 methods. Now we are going to discussing about the Ferris method. So this is the testing procedure for the Ferris method, measuring the thickness of coating layer of the steel section. At the beginning, we place the probe on the surface coating layer, and then coating layer of the steel plate, and then we read the value in the device monitor and read the readings, record the readings for our reporting purpose, right? Okay, here I'm showing some experiment. There you can see a small, this is the calibration plate. That is also the steel plate, but that is a calibration plate. You can see the plastic layer here. I have kept one plastic that's more thicker than this, and then we just put the plastic layer above the calibration plate, and then we put the probes there, and then we can see the value in the device monitor as the thickness of the coat. This is for the calibration. Same process you can apply for the coating in the real field coating, right? Okay, in the reporting part, you have to include the two things here. that is the steel thickness measurement and the coating thickness measurement. You have to include the basic theory, you have to include the process, you have to include the steps, and then device material that you used to proceed this experiment. Now, I'm going to the next part of the experiment. Here we can see the device. What is this section? This is for the NDT test for the welding that has applied to join the two steel plates, which is also called the ultrasonic testing. The objective of this test is to gain the experience and understanding of the types, advantages, and applications of the ultrasonic test methods. This is the device, this is the equipment that we use to detect the defects on the weld, which is also called the ultrasonic flaw detector. You can see three parts here. That's number one is the body of the equipment. Number two is the connected cables. Number three is the props that we discussed in our previous slide, and we'll discuss later on. Okay, this is the small example how we test the how we use this ultrasonic testing equipment to measure the defect on the welding. A basic principle of the ultrasonic test for the weldings are shown in this slide. What is the basic principle? Ultrasonic testings are usually use a high frequency sound energy to measure the dimension and the defects on the plate. That is also called the flaws. Okay, basically we use to measure the dimension of the plate, dimension of the defects, and also the location of the defects, type of the defect that we can see by using this equipment. Okay, it can be used to detect and evaluate the flaws, measure the dimension, identify the material density as well. And this ultrasonic testing equipment consists of the several units such as pulsar and receiver, and that produces the high voltage electrical pulse. And then next one is transducer. You can see in the figure. Next one is transducer, and the transducer helps to generate high frequency ultrasonic energy. And then finally, it displays the display unit, displays some graphs and values that helps to indicate the type of the crack and location of the crack. Okay, so you can see in the figure, there are two types. If we want to measure the thickness of this plate, the wave, you can see, the wave is transferred from the top surface to the bottom surface. When it reaches to the bottom surface, then the waves are written, and that waves are received by the transducer and passes to the device, and the graphs are displayed there. And then we can see for this case, there is no crack. So the total thickness, the distance between these two peak graphs at the start and at the end, that shows the thickness. And and if there is the cracks or defects inside the plate, then the waves are written from the intermediate part, and there will be some peaks at the intermediate part of this initial pulse and the backward echo. So which indicates that there are some cracks, some voids, or some defects within the plate. So this is the process that we follow in this experiment. Okay, ultrasonic test, basic principles. I'm continuing this part. Here we can see how mechanism, how it works during the testing process. At the first, it produces the sound energy. The device produces the sound energy and propagates through the materials in the form of the waves. And if there is any discontinuity, any defects within the plate, in the wave path, the part of the waves return back from the floor surface, and then the reflected wave signal is transferred into an electrical signal by the transducer, and which is displayed on the device screen. After that, knowing the velocity of the waves, travel time can be directly related to the distance that the signal traveled, right? If we know the velocity and travel time, then we can find the distance traveled by the wave, and that gives the thickness, that gives the location of the defects. Okay, next, from the observation of the signal, we can observe the pattern of the signal to identify the location of the reflector, that means location of the defect, and we also can determine the size of the defect and its orientation as well, and different features of the defects that can detect by using this principle. Okay, basically we have four type of the waves that can generate by this device. They are longitudinal wave. You can see in the figure, longitudinal wave, that is also called the compression waves. And next one is shear waves, that is also called the transverse waves. And next one, here you can see, I think all of you know about this longitudinal wave and transverse wave. I think you did the experiment in the physics, right? In the experiment of, the school level experiment. Okay, and the next one is relic waves, which is also called the surface waves. And the next one is Lamb waves. I will show a visual for these two waves later. Here we can see the longitudinal waves, how it produces. If we use the straight probe, right? If we use the straight probe, then it produces the longitudinal waves to measure. And next one is inclined probe. I will show later. This inclined probe is used to measure the defect located inside the plate or inside the weld. The orientation will be not in a parallel, right? Okay, this is the relix waves. You can see how it moves. I think second figure shows clearly, right? It's more better than first one. Okay, this is the Lamb waves. How the waves are propagated from origin to the back surface. You can see in this figure. Okay. Now, what are the advantages of this ultrasonic testing? The basic advantage is that this is very sensitive, so it can detect minute defects. It can detect very small defects as well, like porosity defects. And then next, high penetrating power. It can penetrate a larger thickness. So we can measure the thickness of the large section, the bigger section. And next, it has the higher accuracy. So it can measure the probe position and the size as well. And next, this is the faster, the faster process. This testing is faster than other because it can display the result within a second. We don't need to wait for some time, right? So it's faster. And the next one is we need to access only one side. We don't need to access from both sides. So we don't need to keep the probes at the both sides. We just need to keep at the only one side. So this is also the advantage, because in some cases we cannot go to the another side. If you consider the pipe, right? You cannot enter into the pipe. So we need to measure the thickness from the only one surface, from the outer side. So this is the advantage. And what are the limitations? What are the disadvantages of these methods? If we have the highly irregular geometry, unfavorable geometry, then the problem occurs during the inspection. We cannot inspect properly. And the next, the inspection of material which has the coarse grains. That for that case, this test, ultrasonic test, is not better. It is difficult, right? And the next, it requires the use of the couplant. We should use the couplant. Why we use the couplant? Because we have to protect the wave that propagated, that originated from the device, right? If that goes outside from the probe, then the wave cannot transmit properly through the testing object, right? So we have to put the gel. Otherwise, the wave will be disseminated outside. Okay. And next, defect orientation affects the detectability efficiency, right? If the defect orientations are different, obviously the defects are not like that we expect, right? There are many kind of the defects. So the orientation of that defects may affect to the result of the UT testing. And we need to calibrate the equipment before using. It's a very important part for this testing. Otherwise, the results will may vary. Okay, next, the surface, yeah, in practical cases, the plate may have some rough surface, right? If we want to measure the thickness and defects of that rough surface component, then the result will be deviated. So we have to prepare the surface. That is also a kind of limitations of this experiment. Okay, now I'm going to show something in detail. Okay, actually, ultrasonic testing using the angle probe are used for the welding. What is the angle probe and what is the straight probe? I will demonstrate later. Okay, in the ultrasonic test of the weld, we have the two components. Basically, we have the two type of the transducer, that is the straight probe and the angle probe. I'm telling transducer and probe, both are the similar words, right? So don't be confused. Okay, straight probe and angle probe. And there are the two cases related with the probe types, that are straight probe is used to detect the defect parallel to the surface. You can see the defects I will show later. And then next one is case 2, that is the angle probe is used to detect the defect if defect is not parallel to the surface. This probe is the straight probe. You can see here, and this is the angle probe. This is the another side of the angle probe. So somebody will be confused because this angle probe has the smooth surface, the parallel surface. We cannot see the angle here, so somebody will be confused. But inside this, there is the the angle configuration, right? They have the inclined configuration to produce the angle beams, right? Okay, so these two probes are used for different purposes. Straight probe is used to detect the effect, to detect the defect which is parallel to the surface, and the angle probe is used to detect the defects which is not parallel to the surface. So, yes. Straight beam techniques are used to measure the thickness. Basically, it can also used to measure the thickness, and it is also used to detect the crack which is parallel to the surface. Here you can see some graphs how to measure the thickness. First, we put the probes at the surface of the plate, and then we start to give the waves, and then that waves is back to the transducer again, and this probe helps to send the waves to the device, and then the device calculate the length, as I saw the relation in the second slide, I think. Then we can see the depth here, right? Depth of the plate. Okay, this is the graph that shows the thickness measurement of the plate by using the ultrasonic test. But actually, in our objective, we are not going to measure the thickness of the plate. We are going to detect the defects which is parallel to the surface by using the straight probe, right? That is main task. Next one is angle beam techniques. It is basically used to testing the weld, and then pipe, tubing, sheet, and plate materials. And the object with regular shapes can also inspect by using angle probe methods, where straight beam units are unable to contact all of the surface. These two are the examples from the ultrasonic testing methods using the angle probes. In the first figure, you can see this is the good welding, right? Here we cannot see the defects because the probes, the beams which are produced by the probes are passes clearly, right? That has not, if there is not defect, the waves are not returned back. So this is the good weld. There is no defect. If you see in the second figure, you can see defects. Small voids are here, and if we produce the beams, wave beams, then that goes to the to the void, and that returns again to the again from the void surface to the original surface, and where the receivers are there, and then that will helps to show the defects in the monitor, right? Here we can see how we detect the void. If there is a void at the intermediate part of the graph, there is a one peak which has the maximum, which have the bigger value of the frequency amplitude, right? You can see this in the monitor. It helps to detect the void in the weld. Okay. Now this is the, there are two cases of the probe position. It depends on the apparent depth. I will show in the figure what is the apparent depth. In the first case, if the first case is used if d is less than or equals to t, and the second case is applied if d is greater than t. If we see in the first case, where the probes are located nearer to the weld, right? In that case, if we have the, defect inside the weld, then the wave passes in an inclined surface, and then we can measure the thickness, measure the location of this defect directly by using a simple relation, right? Sine cos relation. We don't need to do more formula. We don't need to create the more relations, mathematical relation. So it's very easy if we keep the probes nearer to the weld. If we keep the probe far from the welding area, then the beams, the wave beams are reflected, not passes directly to the defect, right? So it reflects from the surface and goes to the defect surface, and then we need to calculate this position of the defects. How we calculate? We use simple relation. First, we determine the apparent depth. What is the apparent depth? We just take the projection of this defect, right? And then the beams are straight now, the inclined, and then we can find this length. What are they? How we calculate? We just use the sine cos relation, and we can find this t. And our task is not to determining this t. Our task is to determine this t dash, that is called the exact depth, the real depth of the defects, real location of the defect. So how we determine this? We use the relation t dash equals to twice t minus t. So our device use this relation to demonstrate the location of the depth d dash, right? This is the basic principle that we used behind the result, right? Result displayed in the monitor. Okay, now ultrasonic, basically angle probes are used to test the welding, to determine the welding defects. So here you can see the plates. This is the standard plates where we can see the weld, single pivot joint that is joined by the weld, right? Okay, here you can see some nomogram for the ultrasonic test equipment. This is here. If you see the graph, this is the initial pulse. This is the flaw graph due to this peak due to the flaw, and this is the arrangement of the transducer, which is also called the probe. And this is the flaw. That means defect within the weld. And this is the ultrasonic waves that passes from the transducer inside the plate. Okay, now inside the weld, there may have different kind of the defects. So this figure shows some kind of the defects that probably that may have inside the welding area. I will discuss this later in detail. Okay. Here we can see the angle probe for the welding. You can see a graph. I have shown this place already. So this is the configuration, how we keep the transducer and how we locate the depth of the flaw and how we see the graphs here. Basically, if you see in this graph, right, at the intermediate part of the graph, other graphs, the amplitude of other locations are very small, right? But at the intermediate part, there is a high amplitude. What does it mean? It means there is some defects, so we can predict. So now we are discussing about the various types of the defects that that will be in the welding area, right? First, this is the incomplete penetration, right? Incomplete penetration. You can see the red mark here. The welding methods are not applied properly, right? There is some gap. And next one is lack of the fusion, right? This part, the welding methods are not fused properly. And next one is overlapping. And next one is porosity. There is some voids inside the welding material. And next one is root leakage. Next one is undercut. And next one is slag inclusion. I think you know about this slag, right? There is a small layer material, I mean the small thickness material, and that will reduce the strength of the weld. That slag will produce during the welding time, right? Okay, next one is the crack, right? Okay, now these three tests are not needed to test by using the ultrasonic, right? UTM machine. Why? Because this root leakage we can see by naked eye, right? We don't need to use the equipment. Similarly, undercut we can see here, this part. And for the overlap, we can see here, right? So for these cases, to identify these three type of the damage, we don't need to use the device. So we just need to use the device to identify these 5 kind of the defects within the weld. Okay, let's see. This is the cracks, right? How we detect. In reality, we can see the crack in the weld like this. How we predict during the test. If the scan envelope looks like this, then we can tell this is the welding cracks. We can predict, we can observe, right? And in the monitor, you can see how we identify the crack. There are 2 peaks, right? 2 peaks. So this is the graphs for the crack detection. Okay, next one. This is the incomplete penetration. I mean the lack of the penetration. There is no welding material here, right? This is the weaker portion. It may cause the damage in the structure. Yeah, in the figure, you can see clearly what is the meaning of lack of penetration. How we detect during the test by, if the graphs are shown like this, then we can say this is the incomplete penetration. And similarly, how we determine the incomplete fusion. Yes, this figure shows the incomplete fusion. And how we determine if the graphs like this, right? Then we can tell this is the incomplete fusion. Another one is slag inclusion. That means the void inside the weld, right? Small voids, porous inside the weld. So for the scan envelope, for the slag inclusion, looks like this. And similarly, porosity, okay, there is the air pocket inside the weld, and how it looks in the graph, I mean in the signal at the monitor of the device. This is the symbol for the porosity. Okay, now I'm going to explain about the steps, what we need to do during the test for this welding, right? If you see in the parts, we have mainly, I have explained already, but again, I want to tell. Okay, in this device, we have 3 things. Mainly, we have 3 things. That is the main body. That also includes the monitor, right? And then some keys to adjust the parameter, right? And then next, this is the connected cables. And the next one is props. It is also called the transducer, which helps to change the electrical signal to the sound wave, right? And then next, at the beginning, we should, in this test, we are using the UT flow detector graph, echograph, the number of this device, I mean the standard of this device is 1095 ultrasonic unit. Yeah, we are using this device, right, in this experiment. So you can write in your report this the name of this device, right? And then next, use two types of the props, straight props and the angle props. I already explained why we use these two props, how we use these two props, right? Basically, these two props are used to measure the defects at the frequency of 4 megahertz. You have to be careful about this value, right? Yeah, you should set at the beginning of the test as a 4 megahertz, right? That is the frequency of wave. And next, select the appropriate coplant. You cannot choose any kind of the coplant because that may cause to corrosion to the plate, right? Corrosion to the steel structures. So we don't need to, we are not allowed to use any kind of the coplant. We have selected kind of the coplant, so we should fix before the experiment. Okay, next, carry out the calibration before the test. During the calibration, you have to follow the standard that is provided by the manufacturer, right? The next, in the detailed steps, I'm going to tell some steps, some points. At the beginning, we apply the coplant on the surface of the inspecting area, okay? And the special attention should be paid to the location of the possible cracks. Yeah, these lines are some doubtful, right? How we know the cracks inside the world, right? What we can guess, we can just predict by observing the outer surface. Let's see in the crack, right? Crack type, the defects like the crack, then we can predict from the surface. So you can observe that defects by observing the surface. And the next, a discontinuity like a crack produces the peak on the screen. You have to observe in the screen carefully. If there is some cracks, if there is some defects, the peak of the waves will be increases, right? And then attention should be given to the movement of the possible peaks caused by the cracks to identify the type of the defects, right? As I shown in the previous slide. And carefully monitor the displayed graphs to predict the flaw type detection. And the last part, what we should do in your report, what things you have to include in the second part of this experiment. That is, you have to include the measurement of the defects by using the straight prop. And next is you have to include the discussion about the measurement of the defects, the measurement of the defects within the world by using the angle props. That is your task, right? And try to explain how you observe these things, how you predict the type of the flaws within the world, and something like that, right? And finally, you have to show some results and discuss about the experimental procedure, about the theoretical part, and then about your result, right? If there is some deviation, you have to give some reason why that are causing, right? Why the deviations are occurred, something like that. And finally, you have to give your conclusion for your experiment. Okay, thank you. These are my presentation. Now, our TA will demonstrate some visual for the experiment. Okay, thank you everyone for listening this presentation. Sarania, can you please unmute? Hello.
Yes. Yeah. Okay.
Yeah, tell to the student how they need to prepare the report, how they get the marks, right? And then show some visuals. Okay, thank you. Thank you, everyone.
Do I need to share the video again?
Yeah.
They already.
Yeah, please, if you can share the video.
I think they can play personally, right? Because we already uploaded. If it's okay. Then
okay. So students, do you want to see visual now?
Because I will display again the same video that I was uploaded in the morning.
I see.
So
Okay.
anyone need again it's the same?
Okay. Have you got that video? I'm asking for the student. Have you got that video? Hello, everyone.
Yeah. I see that.
Okay. Okay. So yeah, I will also keep this record. I mean, the record of this presentation and of this meeting. You will get this, right? And then you can see the steps that I demonstrated here. Okay. So Saranya, please tell them how they need to prepare the report and
Yes,
how they
okay.
get marks. Okay.
Okay.
Can you open your video?
Yes, my one.
Okay. Yeah.
Okay. I think maybe not clear, I'm not sure.
It's okay. But they just want to see you, because if they have any questions, they can meet you later and ask. Okay.
Yep. And I have to share one thing for the second part of the experiment. I couldn't show the values for you in the experiment video because that time the machine cannot be operated as some situations. So I think for the report, you can just explain how to do and the theoretical parts, but no need to the calculations for the thickness for the experiment 3.2, but for the 3.1, for the steel plate thickness and the coating thickness, I already show the values for you. I think more than 3 values. So you can note down that values and take average and can show the calculation for that part.
Can I say something, Saranya?
Yes.
Actually, the second part, right, in the 3.2, we don't need to measure everything that I have discussed here, right?
Yes.
Our objective is very simple. What are they, I think just to know about the things, just to get the experience, how to use the device and how
Yes.
to see the signal, something like that. So you don't have to pay much time to prepare the report for this section, right?
That's why for that part, I asked them just write a small description about how to use and the
Yes.
benefit of that one in the
Yeah,
report.
at least you have to try. I mean, all of you have to try to include the, the defects types that I have shown, right? And mention about those things clearly in the report. That is okay, I think. That is perfect, right?
Yes. And
Okay.
students, if anyone not understand how to do report, and please you can ask personally. It's okay.
Yeah. And the next one, when they have to submit the report, deadline. I think they want to know
By
about the
next week,
deadline.
only 1 week. Next
Only
next
1 week.
Monday.
So all of you have to submit the report the next week. I think at the Monday, right? You can submit
Monday.
within the Monday.
Yes.
How
Okay.
can we submit the report?
I think yeah, you can submit the report by by the classroom, right? You can, or you can email to the Sarania. You can get the email from the classroom, I think, right? Otherwise, you can send. And you need to prepare the report digitally, right? So you have to submit the soft copy. No need to give the hard copy, because this time we are doing the online class, so you have to send the report online, right? Is there any questions? You can ask, right? This is the class, so you can, if you have any questions, you can ask. Hello?
You can
Yeah.
the email or
So you want
to submit the report. I mean the submission. Also, you can assign the classwork in the Google Classroom.
Yes. Okay. We will assign a classwork. Yes.
or
Okay.
you can send the email in the chat box here now.
I think it's better we will create a assignment
Group,
in the
right?
classroom.
Group.
Yes.
Okay, that's okay. That's
Yes.
fine. Okay. Yeah. Sharanya will check your report and she will give the marks. And if you have any questions, we are available anytime. You can ask, right? Yeah,
Just
thank you everybody for
okay.
your
There,
presence, for your attention. Yeah, please.
yeah, there is one questions. Do you have to do an objective and procedures? I think just write the objective. No need to write the procedures. Just write the objectives and write the results and your discussion. No need the procedures.
I think that is okay because you know already, right? So yeah, all of you know already about the steps, so you don't need to write the procedure. Just need to include, I think, at least theoretical part and the material and devices that you used, right? And then your objective, so you have to put the objective, what we are doing, right, at the beginning, and then material, and then after theoretical part, and then after you don't need to put the procedure, you just need to give your result. And then finally, you have to write some discussion at the end, right? So I think the value, they can see the value of the measurement from the video. Am I right?
Yes.
You have mentioned, you have shown the results in the video clearly for the first section of the experiment, right? Sharani, am I right?
Yes.
Yeah.
Yes. I'm writing message to them.
Okay.
I'm sending them.
So yeah, please pick the value from the video, see the value in the video, and then you can put that value in your report and make a discussion, some discussion, and give some conclusion. Okay, that's all. Thank you, everyone.
Okay, thank you.
Okay, bye-bye.
Thank you.
So now I'm leaving the meeting, Google Meet now. I just want to stop the recording.